Here we go. Lesson 2.3. We're dealing with congruent triangles here. Whoops, banging the table. Okay, so our job is to get this triangle to sit onto this triangle. Okay, all right. Let's see here. I can just move this whole triangle over. And I can put A on A, and that doesn't quite work, does it? If I rotate it, I'm rotating the other one, I see. All right, let's try that. Let's go back, let me refresh that. Can I just move this one? Oh, it won't let me move this one, I have to move this one. All right, so here we go, I'm gonna put A on A. Now if I start to rotate, maybe I can do this. Get A on A, it looks pretty close. Pretty close. But it's not going to fit. And if we look at it, we can tell why. Look, B and C prime. So A might be matching up with A prime, but B and C are not supposed to be connected. It's supposed to be B and B prime together and C prime together. So let's see here. Maybe if I reflect it, let's see here. Okay, now it's all flipped around. Okay, let me try this again. Let's see here. I'm going to put A on A. Move this over so I can see it a little bit better. And then I'm going to rotate. Start rotating. Oh, okay, it rotated off. I guess it's rotating by the center of the triangle. So we'll put it like this, and then we'll try and move this over. Oops, move this over. And there we go. This is looking more promising. There we go. And it matches perfectly. Ta-da! So what has to be true if these two triangles are congruent? Well, we just showed it, right? There has to be a sequence of rigid transformations that cause one to overlap perfectly on the other, perfectly cover the other one. And notice that we didn't stretch or bend or twist or shrink or anything like that. The shapes, right? The shapes stayed exactly what they were. We just turned them, rotated them, we slid them, translated them, or we reflected them like a mirror, right? So that would be the answer to the first one, right? Okay. What might be true? Well, it could be that if we had this set up, maybe there would be a situation where we can do it in one step, but there isn't in this case, okay? They're talking about in some general example, okay? Now, it looks like I can actually shift this so that it turns into what could be considered an equilateral triangle, and then I could try and move this and make it fit, even though B was going to C and C was going to B. Let's see here. All right. There might be a way to do it, but you'd have to get it perfectly, right? So that the triangle was perfectly equilateral. Even with all my twisting and stuff, I couldn't quite get it right. But the idea is that it could be that you could make it fit if it was a regular triangle, right? Perfectly regular, meaning equilateral, meaning all the sides are equal, and equiangular, meaning all of the angles were equal. So there could be more than one way to make it fit, but as we were given the triangles, I suppose you could say there might be 2 steps that you could do instead of 3. Up here we had to do 3 steps to get this into place, right? We had to reflect it, and we had to rotate it, and our translation would cause it to get perfectly in line. So the possibility is that it could be done in fewer than 3 steps, but we don't know, right? If you were talking about a different set of triangles. So what definitely can't be true? Well, what can't be true is that what can't be true is that the parts of these two triangles can't be different from each other. Angle A, right here, this one, has to match angle A prime. Angle B, over here, has to match with angle B prime. And angle C has to match perfectly with angle C prime. And you could say the same thing about the sides, right? AC has to be the same length as A prime C prime. AB has to be the same length as A prime B prime. And BC has to be the same length as B prime C prime. So there can't, what definitely can't be true? Well, there can't be parts of the triangles that aren't congruent to each other. Every single part of the triangle has to match. Okay? All right. On to task 5. We're skipping task 5. We're skipping task 6. And we're going to task 8. We're skipping task 7 as well. Okay? So we're going straight to task 8. All right. Task 8. Noah and Priya were playing invisible triangles. Okay, so Priya says that these two triangles are congruent, but Noah can't see them. And so he's trying to figure out a way, right, a way to get one of them to land on the other one perfectly. Okay, so the first thing that he does, and I'm going to use this this space down here to do diagrams of what happens, right? So the first thing that he does is he translates triangle ABC by the directed line segment from A to D, right? So he does this. Oops, I wanted to use green. My bad. All right, there we go, green. And he does from A to D. Now, why does he select from A to D? Well, let's see. Let's look at the congruent statement up here, right? A, B, C in that order, and D, E, F in that order. So A has to match with D, and B has to match with E, and C has to match with F. It even says it over here. Angle A is congruent to angle D. Angle B is congruent to angle E, and angle C is congruent to angle F. Okay, so he says, I'm going to put A on D. Okay, so that's what he does. And he moves this triangle up here. He moves this triangle, ABC, up here so that A sits perfectly on D. Okay, now, I'm going to have a hard time drawing this, but you guys can get an idea. Actually, you know what I'm going to do? I'm going to check it. I'm going to go like this. So there's AB. Okay, and then we'll do this again. Here is AC. I'm going to move that up there. Okay, and then here is BC right here. All right, and I'm going to move that up there. So that's what it looks like after the translation, just sliding it over. Okay, then what he does is he says, using D as the center, right? He's going to rotate this triangle right here, using D as a center so that rays AB and DE line up. So this is AB, okay? This is, I can't change the color of that, unfortunately, but I can put some stuff in here. I'll put a text in here. So this is now point A prime. It'll also be A double prime and all that sort of stuff every time we change stuff up. This is now B prime. And this up here is C prime. Okay, so now that we can tell what has happened, right? We've slid this up here. He says that he's going to use D as the center, and he's going to rotate until AB, ray AB, which goes on forever here. If this is point A, well, it's now A prime, right? So that rays A prime, B prime, which goes on forever out this way, lines up with DE right here. Okay, so he's rotating this triangle counterclockwise. He doesn't know if it's counterclockwise or not. He's just saying that he's going to rotate it that way. He's going to rotate it until this A prime, B prime lines up with D, E. Okay, so the angle that he's rotating by is actually B prime, D, E. Okay, all right. So now this triangle changes, and I'm going to have a hard time drawing it. This triangle now, let's see here, can I do this? Now it looks like this. Let me see if I can draw this without totally screwing it up. Okay, so after the rotation, it looks something like that. And now B double prime is up here. B double prime is right there, okay? Right next to E, or it's on E, it landed on E. And then this out here is C double prime. All right, great. Okay, so there's that triangle. And then he says, we're going to reflect the image of this. This is A double prime, B double prime, C double prime. This triangle right here is going to reflect that across line DE. Because he's gotten DE to match up, this triangle is going to flop down and match the other triangle perfectly. Okay? Okay, awesome. So, Noah and Priya have to figure out why their steps worked. Okay? Why did their steps work? Right? So here are the questions that get asked. We know that ray A double prime, B double prime, and DE line up. Okay, so because we said that we were going to rotate by this angle. But why do we know that B double prime and E have to be in the exact same spot? How do I know that when I rotate this, B isn't going to land a little bit further out along this ray that extends forever, or maybe it doesn't quite reach E? How do I know? How do I know? Well, let's see. What information did they give us? So we know it's going to land on this ray. Okay. So now let's see here. Well, they gave us this information right here. Okay, that's the information they gave us. Well, let's see here. AB is, segment AB is congruent to segment DE, right? So AB, that's this piece here with the one tick mark, matches up with DE, that is one tick mark. They're both the same length. That edge is the same length. So as a result, when we rotate this around, B has to land on E because D and A are together. Right? They're sitting at the same spot. And if these two things are the same length, then B has to land on E. Okay, so that's the answer to that question. All right, so now let's look down at the next question. Okay, how do we know that the image of ray A double prime, C double prime, and ray DF will line up? A double prime, C double prime, and DF will line up. Actually, you know what? That should be C triple prime. All right, because this is C single prime, this is C double prime. When we reflect it, C double prime lands down here. The question that they're asking is, how do we know that when we reflect this triangle right here, right, this triangle, how do we know that this point, C double prime, when we flip it over, how do we know that it's going to land exactly where point F is? No, excuse me, my bad. How do we know that it's going to land exactly on this ray? This is a tough question. How do we know that this is going to land exactly on this ray? Well, we're reflecting it, right? And so this edge right here is the edge that we're reflecting across, right? This DE edge right here. That's the edge that we're reflecting across, and I'll just, okay. So there you go. That's our line of reflection. All right. So when we're reflecting, what is it that's telling us where point C is going to land? Well, if this triangle, our original triangle down here, DEF, if this edge is decided by this angle right here, isn't it? The one by corner D, this angle. And when I reflect this edge is still staying the same. When I reflect triangle A double prime, B double prime, C double prime, when I reflect that, this edge still stays the same. So where this edge here, A double prime, C double prime, where that ends up is dependent on this angle right here, right? The angle between B double prime, A double prime, and C double prime. This angle right here. Okay? All right. And that's the original angle right here, right? BAC. So it's this angle right here. Well, when I look at that angle, because that's what gets flipped, right? If this stays here, that angle goes over on this side. This angle here has 3 tick marks in it. And look, this angle here by corner D also has 3 tick marks in it. So those two angles are congruent, so they're the same. So wait a minute, let me just double check that. Oh yeah, right there, it says it, right there. In this part, it says angle A is congruent to angle D. So those two angles are congruent. And it means that when we reflect this, point C has to land somewhere on this ray, somewhere along this edge. Point C, C triple prime has to land somewhere along that edge. Okay, great. All right. So that's task 10, right? So far we've been using the given information to answer these questions, right? Why do these two line up? Well, why do these 2 points have to be in the same place? Well, because AB is congruent to DE, right? And how do we know that point that A triple prime, C triple prime is going to lay perfectly on DF? Well, that's because of this. Angle A is congruent to angle D, because when we flip that down, angle A lays perfectly on top of angle D. Okay, so now the last piece here, the last question is, how do we know that point C triple prime and F will line up exactly? How do I know that when we reflect this, C is going to land perfectly on F and not like a little bit further out on the ray, or maybe not reach quite as far? Well, if we think about it, didn't we use this information up here to answer our questions before? So let's see, what piece is this? So A double prime, C double prime is this segment right here. It's this segment right here after it's been transformed. And then it gets reflected, so we're not changing the length or anything. And it says it has 3 tick marks next to it. And look, DF also has 3 tick marks. That means that they're the same. Let's check it in the given information. So AC, that's this piece right here, is the same as DF, which is this piece right here. So that means that this piece, which got slid over to here and then rotated over to here and then flipped all the way down to here, has to be the same length. So if A stays on D, then C has to land perfectly on F. There you go. Okay? So that is this lesson. Work your way through the practice problem.